Okay, hello everyone. Welcome to the HEIR meeting once again. So this month we had 70 merged PRs, lots and lots of work going on. That might be our monthly all-time high. I don't know, but we've been doing lots of good stuff. So I'll go through the list. So we start with a lot of the work from Edward at CMU. The Rotom rolled layouts got merged along with an improvement to the bootstrap and rescale placement ILP. I think those are still in development and testing, so they're not at the point where they can be used yet, but there's a lot of progress happening. Um, we also, so I also finished getting in the rolled kernel support for matrix vector multiplication with one caveat. So it's like enabled and tested in CI now. The one caveat is that it doesn't have the support for splitting off preprocessing. So there's updates below about that. We've had a lot of work on the Torch front end and general ML ops support. Um, Including a bunch of improvements to convolution with different size filters with and without pooling um, for materializing like constants, materializing pre-packed constants for stuff like filters. We added support for batch norm, including fusing batch norm into linear layers. We added support for torch sigmoid operator, which that was not working because torch emits like a check for zero assertion, and that was not being lowered properly. So if you have a plain text, now the cf.assert will be lowered and applied. Um, we have support for dilated convolutions that expand the kernel by interspersing zeros in between the filter values. And then we had some work on getting the ciphertext matrix multiplication kernel that we had implemented. It had some slight bugs, and then now we have an end-to-end test. And then I think the end-to-end test became flaky only in the Latigo backend. So we have to figure out what is happening there. Um, and then, and now we have a CI that does torch operator coverage. So it ran 2 days ago, and it said that both conv2D and batchnorm 1D were marked as broken. So I think there's maybe a little bit more work that we have to do to figure out to get them solid. But I thought that was funny because I thought they had gone green, but it looks like some other change had come in that made those particular test cases go back to failing.
So is it only testing for like compilation, not for like correctness, right?
Correct. Yeah, it's just compilation. And so it hits like, yeah, it hits some compiler error. Uh, yeah, okay. So we had some work happening on the front end. There's a lot more in progress. But now basically the Python package is going to have everything be optional except for the HEIR opt and HEIR translate binaries. And then you will, when you pip install it, you'll use what's called pip extras to choose which front end you want. And right now the only front end is the Python bytecode front end. And then that will pull in like the numba and numpy dependencies. And then if you choose the OpenFHE backend, it will pull in the optional OpenFHE dependencies. But that will, there's more to say in progress. But yeah, there's lots of stuff happening to the front end. I also did a bunch of work on bufferizing the backends. So now instead of when you're lowering to OpenFHE or Latigo, before it was lowered entirely in terms of tensors, and then there was some like inefficient code generation to work around the fact that tensors basically copy their data on every operation. And so doing things in place. Now we are going to do proper bufferization, and so this yeah, so this there was a bunch of changes around making bufferization work. And then that also allowed us to reinstate the in-place optimizations for Latigo. And so, yeah, okay. So basically, I think there's still a bit, some more work on the OpenFHE side to do here. But I'm working on that at the same time as migrating OpenFHE to use imitc. Really, only the most hardcore compiler developers will care about this part of the pipeline, but it should reduce the total amount of code required to do code gen for a bunch of C++ based backends, which is a good thing. I also finished working on this debug.validate feature. So there's a new dialect called debug, and then which has a single op called validate. And this basically allows you to insert specific places in the IR at any point during compilation to say, I would like to basically stop the program at this point, call an external function with like the ciphertext and the secret keys threaded through. And so this is useful. Like right now, our old debug pipeline you would enable debug mode, and then at the very end, in between each API call to like an OpenFHE or LATIO op, it would insert a external function call that would decrypt and print out the like decrypted data. This was bad because for large programs, that's like a way too much output. And so this now lets you say, okay, I'm going to decide where the ops go at the beginning, maybe in between each layer of an ML model. And then when it lowers it down, it will only convert those debug ops to external function calls. So now you can do something like measure the precision loss at every step of between each layer of your neural network or before and after an activation, rather than after every single multiplication that happens in like a polynomial approximation of a ReLU function. So I wanted to do a little bit, write a little demo or like write a little tutorial about how to use this, but it probably won't happen until next month. Okay, so work on crypto and the compiler. We have been doing a bunch of performance improvements to various aspects of the low-level polynomial stuff. And then we have been working on improving the key switch, like where the key switch lives in the different dialects. I think we're still not yet at the point where we can do like an end-to-end lowering of the key switch operation to LLVM and have it work correctly. And part of the reason is that there's a bug in the implementation that I still think it hasn't quite yet been fixed. But yeah, so we have at least 2 people who are working on this side of the pipeline right now, and there's a bit of like design issues happening around like so like there's a new modarith op called lift that basically says I would like to go out of modarith to arith and just work with regular integers, but I'm picking which which I guess it's non-canonical, which particular representative of the like factor ring I would like to use, whether it's the centered representative or the standard representative, or maybe there's a different one people use, I don't know. So that replaces the modarith extract op, which kind of by default assumed a canonical standard representative. Okay. There's also been some improvements to split preprocessing. This was because split preprocessing didn't support loops. It will support loops soon. We just need to get the code all in and cleaned up and reviewed. But as part of that, there's a new ephemeral preprocessing dialect that basically the compiler introduces and then cleans up before the end. So end-to-end users will never see it. But what it does is it separates the process of identifying which parts of the IR can be pre-computed and extracted. So there's like that step. And then there's a step of like, how are all of these plain text laid out in memory and sent back into the program? And so that memory layout step happens later, sort of at the end of the pipeline. And then in the middle of the pipeline, this just deciding what ops can be extracted and putting them into a separate function is the preprocessing dialect. So yeah, so that's like something I'm continuing to work on. And then we wanted to do polynomial constant folding. Okay, so when we're lowering all the way, this is more crypto and the compiler stuff, but when we lower down to polynomial dialect, we end up having an NTT solver that decides where to put NTTs. And it thinks that an NTT of a constant is free, which it is because the server can, or the compiler can pre-compute the result of that NTT and fold it away back into the IR. Problem is, we don't actually do that. So we don't have any eager constant folding defined for polynomial operations or even modarith operations, I think, is not completely covered. So I was going to go through and add polynomial dialect constant folding. As part of this, I was adding interfaces for doing things limb-wise, because the main obstacle there is that like RNS support is not really I mean, it's supported in the ops, but like the attributes don't have an RNS form, and the folders that do exist don't support RNS. So basically making something that you can define a folder on just a single limb, and then it will automatically upgrade to apply to all limbs, is what these two attributes are doing. And so I demonstrated that by having modarith folders that do work with RNS types already. So that's checked in, and then the next step is to go up to polynomial. Along the way, I added an AP-int factorization optimization and an in-memory NTT that does not depend on OpenFHE. It doesn't use OpenFHE's NTT, but it has an equivalence test that makes sure it's byte for byte equivalent to OpenFHE's NTT operation. And it's about 6 or 7 times slower. So it's just like a short amount of code trying to remove dependencies, but still we'll use that for our constant folding. And if it's really too slow, then we'll figure something else out to make it faster. Okay, on the topic of builds, so the nightly builds now use the PyPI built wheels. So you should see if you ever use the nightly builds for, I think even for HEIR opt or HEIR translate. We were previously just building them for one platform, and now we have HEIR opt and HEIR translate binaries that are built for all of the platforms we support that get pushed up to the release every night. So that's good. And okay, I'll have more to say about the build in a minute. And then we had a number of bug fixes. So there's a bug in our polynomial evaluation that caused noticeable precision issues with like ReLUs lowering, among others. And so that got fixed. There were various bugs in the layout that also has been toiling away at. But now I think most of them are fixed, and we have like the convolution with the row interchange optimization is working and demonstrating efficiency improvements. And then there were, I guess there were 2 independent places where we thought that the compiler was broken, but actually we just had a computation that used numbers that were too large that they didn't fit in the available precision. And yeah, I mean, Mark, it's not your fault. It's happened to me before this, and it happened after, right? Just a couple days later. So I don't know. There should probably be some point at which we find a way to help users with this sort of situation, but I don't have any immediate ideas for that, right? It's like a crypto parameter issue. So okay, anyway, yeah, maybe there's like a way we can run stuff in plain text and use that to come up with a recommended parameter set, or at least warnings or something. But okay, that's food for thought. Okay, and then in progress PRs. So we have more work on Rotom doing the alignment, assignment, and lowering step. We have an emitter for the Cheddar dialect that Alex has been graciously working on. And apparently the community is eager to have it merged in so everyone can do Cheddar benchmarks.
Right. Yeah, actually, on that note, let me post the link here. So if Eric is watching this, or if somebody wants to let him know, the Cheddar branch in my personal fork of HEIR is working end to end. It will probably still take several days to, get this all cleaned up and merged in. But if you want to play with this already, and you don't mind having a long and messy history of fixes and unmerged commits and stuff like that, yeah, this is working end to end.
Excellent. Okay, and then let's see. So on the topic of the front end, so we are removing the precompiled OpenFHE from the PyPI wheel, which had a bunch of issues. But basically now, if you want to use OpenFHE as a backend with the HEIR Python package, you will need to install it yourself, which usually means building it from source because you do need to pass the development headers as well. And then you need to configure HEIR by setting some environment variables in order to point to the path to like the shared libraries and the development headers. So that just got working, I think, yesterday. So it's in review and should get checked in soon. And then when that works, then we will be able to enable finally correctly enable the hermetic LLVM build. I had made a mistake in configuring this and it wasn't actually enabled. Thank you to Mark and the other community contributors who found this bug or noticed it simultaneously. But I have been able to actually get it working properly based on this PyPI wheel fix. And the nice, okay, I'll have more to say about why this is nice, but it's going to be very nice. People will be happy. Okay, so then, yeah, I have when I was working on the folding batch norm into linear layers, I noticed that okay, if the batch norm doesn't have a previous linear layer to fold into for whatever reason, then maybe you could fold it forward into the next layer. And I realized that you could pretty easily fold it into a polynomial eval op because it just changes the coefficients of the polynomial. So I thought that that might be a nice, I haven't really thought hard about like whether this is a reasonable thing to do, or whether it will ever actually be triggered by any real program, but I have it sitting there because I thought of it and then implemented it, and then I was going to come back to it and never did. Yeah, go ahead, Mark.
I think that makes sense because I think they do it in the paper.
Which paper?
The paper. There's a, like, I don't know, every FHE paper needs an acronym, and there's one which is the paper.
Oh, okay. If you could send me the
Polynomial
link, then
approximation
maybe I could look into
something.
that.
I think it's something with polynomial approximations is how they get paper.
Yes, let me find it for you and
Yeah.
post it.
Okay,
in
well,
the chat.
that's good because then I can justify it at least by saying that it's, and then that adds another list of like papers we've ported to HEIR. We can add to the list. Okay, fine. All right, good. I'm glad that at least my idea is not completely silly. But yeah, it was very easy because it's just basically it's just a polynomial composition into an existing polynomial, and like we have all the code for that already. Okay, so on the split preprocessing front, I still have 3 more PRs to merge in to get split preprocessing working. But after this last one, it is working with looped kernels, and everything is nice. And then I have the partial work on doing emit-c to using OpenFHE with emit-c so that we don't have to write our own manual C++ code gen. So that required an upstream fix because the conversion of memref to emit-c doesn't handle custom types. So I have a fix for that just got approved this morning. So I have to clean up some review comments and then merge it in. There was some fix for the scale analysis using proper per level scaling factors. I think that got merged this morning as well. There's also, this was Oscar's huge work improving, like fixing the row interchange for batched convolutions, which I think also got merged this morning. So that should be in. And then I thought that I needed to do with Latigo with the in-place operations. I thought that the compiler was like moving some code around that it wasn't supposed to be moving around. And so I thought I needed to add like memory effect interfaces that says, oh, this in-place operation is writing to this operand and reading from this operand in order to like let it, but it didn't seem to do anything, and I couldn't reproduce the bug that was happening. So I might just leave it and I might just close this PR. But anyway. Okay. Notable recent issues. There was a bug detected in the basis conversion. That was a new contributor from Belfort. So I don't think that's been fixed yet, but it's generated a lot of discussion. There's my work to bufferize the OpenFHE backend pipeline and do emit-c for that. We had we have the new issue to, I guess this is just like rephrasing an existing work stream into like a smaller, more refined ticket, which is just adding an end-to-end correctness test for CKKS relinearize going all the way down to LLVM through our crypto lowerings. I left this ticket open, basically my fusion of batch norm into conv2d. There's other fusions that didn't make sense when it's a batch norm and a non-channel based convolution. And so there's a couple of like extra edge cases that we could implement that I think Mark said that he actually saw this one show up in one where like after the conv2d there was a multiplication by a splat, and then you could just multiply the filter by the splat instead, and then skip a multiplication. There's also a lot of discussion around how to do modarith with centered representatives that resulted in the modarith lift op. And then we had a discussion with the PolP devs. This is the bivariate CKKS scheme that came out recently. Recently, I guess like last year. and they have been working on an implementation in Rust. We met with them to discuss like what would be needed to add Pulpy as a backend, and then I took all of the notes and did some more digging around Pulpy, enough to write like a pretty detailed doc about like the steps involved in adding it as a backend. But I'm not going to do anything more on it. So if some graduate student or some other contributor wants to pick that up, it's sort of fair game. It seems like the kind of thing that nobody currently has time to do, but it would be really nice to have another backend with like a different scheme to test out. Okay, so that's all for notable recent issues. And then before I open the floor for discussion, I wanted to mention Build Buddy. So this is not an advertisement for Build Buddy, but everyone in the community has been sad about how long the builds take. And when we have the hermetic LLVM, so this hermetic LLVM tool chain that I thought I enabled but had incorrectly enabled, makes it very easy for us to use off-the-shelf build farms. And there is a off-the-shelf build farm called Build Buddy for Bazel that is free to sign up for. And if you have the hermetic thing enabled, then you can actually just set an API key in like your build command, or like put it in like a configuration file. And then this will actually run, across like 100 nodes or something, or 500 nodes. And it will cut your LLVM build time from like 40 minutes down to like 5 minutes from like a clean build. So I tested this the other day. So what I'm going to do is I'm going to make the CI use this once we have all the requisite code checked in. So that should cut our CI builds down significantly. And then the second thing I want to do is, for people who are actively working on HEIR, I would like to have like a shared remote build environment, basically like a Build Buddy project that everyone gets the same API key for. And then everyone can, like, basically we'd be able to share build artifacts because it would be all using the same hermetic LLVM, right? So your build would be much faster. And it would cache build artifacts and stuff as well. So I'm looking at having that set up. I think it will still be free. Like that. This is the weird thing about Build Buddy, is that like they're like, oh, you don't, even if you go over the like free budget, we're not going to block your builds. We will contact you if you are consistently going over the free budget and talk about an enterprise plan at that time. So I don't know what that means, but it seems like they're very friendly to open source. And all the people that work for Build Buddy are also all the people that work on Core Bazel, are also the people that work on the Hermetic LLVM project. Like it's like the same developers on all these things. So I like, now I'm like chatting with them in a bunch of different like Slack channels and stuff. So I feel like we are in a good situation to basically get everyone working on HEIR to have fast builds. But yeah, okay. So yeah, maybe in a week, check in with me, or I'll reach out to the core developers and maintainers, and I'll help you get set up with this. But yeah, should be good. All right. Who has a topic? Astra, you want to talk about Lynette?
Yeah, I wanted to like progress track, since like we mentioned the row interchange thing, and like all the ISL bugs are fixed. So now the convolution layouts with interchange are applied as a sequence of layouts. Just FYI, you'll see multiple loops implement the layout assignment for those. And you'll also see a list of layout assignments on the assign layout operation for the filter. And the thing blocking turning interchange rows on for Lynette is to pad the channels so that they're a multiple of the gap factor squared. And I had a kind of design decision question on it. So the first thing is, well, I'm in the background going to run Lynette without the channel, without the row interchange, so we don't need channel padding. But while I'm working on this channel padding situation, if you have a model with like a number of convolutions in a row or a number of poolings in a row, then your gap factor increases every time you have a pooling operation, because the gap factor is going to be the stride, and then it'll accumulate multiplicatively as you go down. So if you have one pooling layer, the gap factor is going to be like, let's say it's a 2 by 2 thing, you're going to have a gap factor of 2. Then you have another pooling layer, now it's going to be 4, and then another one that's going to be 8, and so on. Which means like we don't currently have a way to track the gap factor in the layout. Like we could infer it maybe, but that would be like a very complicated thing to do. I don't really know if there's like, I've been trying to figure out if there's a way that we can naturally figure out what that gap factor is during the layout optimization step, or if I should just add a gap factor to the layout attribute and propagate that through the IR that way.
But the
Does that make
concept of
sense?
the gap factor is like a Orion kernel specific thing, right?
I mean, not really. That's just like the factor that you're going to use to interchange the rows.
Hmm.
It's just like
But it is
it's not
specific to
Orion
that kernel.
specific.
But it is specific to
It's
that
specific
kernel,
to
right?
that kernel. Yeah.
Yeah. Okay.
So I guess
Um,
I could also add a kernel attribute, and because we did have our kernel attributes be like extensible with information, not just the name. So I could make it like matvec with gap factor 2. That makes sense.
Yeah,
And
could do that.
that's my way to propagate the IR through that. It's just that the layout has to correspond to that, which is fine. Yeah. So I think that could work. That
Yeah, I think the other question is like, what's the mechanism for getting the gap factor back to 1 is compaction, right? Like that's so like it seems like maybe there is the alternative design would be that you have a analysis pass that happens before you even start layout propagation analysis that annotates the ops with the gap factor and then decides where to insert compaction ops. And then you have like a dedicated op that represents compaction, and then that lowers or turns into like a layout conversion.
But we have to make a choice, right, of inserting compaction versus
Yeah, versus like delaying compaction, and that would be like
Right.
an optimization that would happen earlier. You know what I mean?
You
Like,
think it
and
happens,
then at
but
least you.
doesn't it have to happen after kernel choices?
Yes, that's true. We don't have any other kernel choices though, right?
Yeah.
So
Yeah,
like
I
that's
guess
what I'm
I
saying
guess
is
like
that this is
my
why
sort
it
of
makes it
question.
feel like it's kind of specific to, when I say specific to Orion, it's like it's specific to the way that Orion did their layout choices, where they said, okay, we're going to have this concept of a gap factor that accumulates, and then we're going to like manage it
Mhm,
ourselves,
mhm.
which doesn't fit in necessarily in like a, I mean, you could, I guess you could fit it in like a general purpose packing solver. But yeah, I was
Yeah.
thinking that's like an alternative. Alternative is you could decide in advance where to put the compaction ops, and then you don't need to track the gap factor anymore because it would be handled automatically by the inserted compaction ops that turn into the appropriate
Right.
convert
Yeah, but it's
layout.
like I think that might be part of layout propagation then.
Mm.
If layout propagation walks the IR and decides, wait, I thought we had the room for the entire time.
Uh-oh.
Um, I think we do.
Okay.
One sec. Oh, um, okay, yeah, he's fine. All right. What I was saying is I think that's part of layout propagation, assigning the kernels. Like saying, okay, we're gonna assign an Orion style kernel to this with a gap factor of this. We walk the IR, and we could insert compaction steps at each one and not track the gap factor. And then layout optimization can always push
Drop
the
drop
yeah,
a compaction op. Yeah.
drop the compaction into a higher gap factor for the next operation.
Right. Yeah, I think that's, and but like it seems like layout propagation, layout optimization, and those two passes are just becoming like the Orion packing solver,
Right.
right? Rather than like having it tried to pretend to be general purpose, and then we just have alternative packing solvers.
Because my feeling is also like, I don't know whether like how much I should invest in.
Yeah, I mean, I would say don't invest too much in it, and I think that like to the extent that we can hard code assumptions into it, I think it's fine. And
Because I
so
think
like if we're hard coding the assumption that this convolution thing only has one kernel that has this concept of gap factor, what I would prefer not to have is to have that information leak out into the design of the layout attributes and stuff itself. Like it should be something independent, because then
yeah,
any other layout optimization pass
yeah,
shouldn't have to think about a gap factor if it's
I
not relevant.
agree. I think like the easiest way to like make this sort of more seamless into it is treat the gap factor as part of the kernel operation.
Mhm.
And then yeah, treat that as an attribute on that type of kernel. So
Yeah.
we're gonna implement a convolution with a matvec diagonal with a gap factor of 2.
I think that sounds good to me. Yeah. Um, And then
And
you,
then that way I can like propagate that as I go. And I think I will just test that without the compaction steps because I think the compaction steps are quite expensive.
Mhm.
I'm not really sure if they're totally worth doing.
Mm.
I guess it's in the long tail, it would probably be worth doing if you accumulate a gap factor where like you could compact to such a small number of ciphertext in comparison, then it's worth
Sure.
it.
Sure.
So I guess what I'll do is, at least for the sake of Lynette, I think I'll treat it as a attribute on the kernel.
Yeah. I mean, you could also say like, just like stop at 8 or something, right? Like
Mhm.
as a heuristic, let a parameter decide like how large the gap factor is allowed to be and just greedily compactify it or recompact it.
Yeah.
Yeah. Okay.
Oh, but and then the other news, I guess, is like I'll share a little bit of if I run the pooling test. So there's like a single pooling layer that's like 14 by some 10 by 10. It's like 14 by 28 by 28 that goes to 14 by 14 or something. It's the first step of net. With the interchange rows being false to interchange rows being true, it speeds it up by a factor of like somewhere between 2 to 4x in speed. So quite a bit. And then the pre-processing time as well will cut down more than 4 times. Like in a particular example, it took 20 seconds to pre-process and then it took 1 second. So I think like 1,000 diagonals can sometimes go down to like 60. So that's a lot less packing to do. So all in all, the performance might go up. So yay.
Yay.
Now we just have to do pooling layers and convolutions, which
Yeah.
is blocked on that first bullet point.
Very good.
And this compaction, is it already in the code or is it something you're designing? I didn't catch that.
So compaction would be modeled by a layout conversion operation, which would use VOS Erkin, I think. Like unless we have like some smarter way of doing it, it would use the existing layout conversion lowerings.
And I think it would probably just say like take whatever the current layout is and convert it back to a row major layout or whatever layout is needed for the next layer.
Mhm.
Okay, thanks.
All right. Any other topics?
I have offline topics.
Okay. I'll wait till the
Online
end.
topics.
Yeah. Mm. Okay. I guess we can cut it early then if there's no other topics. I can't think of anything specific.
I wanted to talk a little, like since Edward and Alex are here, I wanted to talk a little bit about convolutions, but yeah, that's not hair related.
Okay. Yeah, sure. Alex, you're muted.
If you want to ask me questions about the thing you discorded me about post-recording, I'm happy to answer those too.
Okay. Okay. All right. Then we'll stop the recording here. Thanks everyone for showing up.